Okay, so the goal of this lab is to actually come up with the solubility rules without looking at the solubility rules. So just based off our experimental data. So what you're going to have here is we have 12 different solutions, and we're just going to mix them in all the different possible combinations that you can. And then observe what happens, and then from there determine what things are soluble and what things are insoluble. So the goal of this lab is we're looking for which things are a precipitant. So just a reminder that precipitant is when a solid forms when two aqueous solutions are mixed. So the aqueous solutions means that with all these given solutions that we're starting with, all right, so all of these and all of these, they are dissolved in water and dissolved to the extent, because they're ionic, that they've separated into their different positive and negative ions, right? So you have positives and negatives floating around in each of the solutions. And what happens is that when you pour two solutions together, if the positive and negatives have enough attraction to each other versus the attraction that they feel with the water, then they'll link together and become a solid, which we can then see with our own eyes because it becomes cloudy or a different color or something like that. If by chance they don't feel that strong of attraction to each other, then we won't see a reaction happen because nothing links up and everything just remains as what we would consider spectator ions. So before we jump into the lab, I want to review solutions a little bit and what molarity is. So what we want to do here on this pre-lab question is show the math and explain in words how we could prepare 100 milliliters of a 0.1 molar solution of silver nitrate. So pretty much I want you to explain how these solutions were made. So the goal here is we want a 0.1 molar solution. So if we recall, molarity is, so 0.1 molarity is moles over liters. And so in terms of practicality, the thing you have to remember is in labs, silver nitrate is a solid compound. And so to make a solution of it, we need to dissolve it in water. Now we know how much water we're using to an extent. We're using 100 mils is what we want in the end. But we need to know how much of our solid we need to measure out. So our first step is we need to know how many moles would be in a 0.1 molar solution of 100 mils. So I'm going to put 100 milliliters in for the bottom. I'm going to change it to liters. So we're going to have 0.1 liter over, I'm going to just put X for moles. Sorry, I'm going to use this pen here. And then we have equals 0.1. Okay, so if I move liters over to the other side, we end up with X equals 0.01 of a mole. So that's how many moles of silver nitrate we want to measure out. Now, once again, in terms of a lab setting, we can't directly measure out a mole because a mole is a counting number and we can't count out a mole of something or even 0.01 mole of something. So we now have to convert moles into grams. So mole to gram correlation is the molar mass. So for 1 mole of silver nitrate, it has a molar mass of 169.87 grams. And that is found in two ways. With a lab setting, you can actually look on the bottle of silver nitrate and it will tell you its molar mass. In not a lab setting, you can just go to the periodic table and you would add up silver and nitrate. So we times that through and we find 1.69 grams. So to make our solution, what we're doing here is we would say, so in words, that we are going to measure out 1.69 grams of silver nitrate and dissolve it in enough water to make 100 milliliters. Now, the reason why we say enough water is you don't measure out the water and solid separate and then pour them together, because then technically it would be over 100 milliliters. But instead, you put the solid in to the flask first and then fill it up to 100 milliliters. Okay, so while you watch the lab, this is the data table that you'll refer to. So there's two different parts. You'll notice the paper has part 1 and part 2 on the back. And these are all the different possible combinations of how we're mixing. So in these boxes here, you're going to write two things. Number one is you're going to write your observations. So whatever you see happening in the video, Well, that is lovely writing. In terms of like, did it go cloudy? Did it stay clear? Did it have a color change? Key thing we're looking for is, once again, if that precipitant was made or if nothing happened because they're all spectators. The second thing you're then going to do in each of these boxes is you're going to write the possible products of the combination of the two things that are being mixed. So for example, when I mix silver nitrate here, sorry, don't mind Becker here. Silver nitrate with barium chloride, how do they trade partners to make new products? So the biggest thing to remember is that the thing to remember is that these things are floating around as ions. So silver nitrate is actually floating around in solution as Ag plus and NO3 minus. On the other hand, the barium chloride is floating around as Ba2 plus and Cl minus. So when they have the possibility of trading partners, right, negative is going to pair up with positive and you have to balance out their charges. So it's +1 for silver, -1 for chlorine. So they could come together as AgCl. Okay. On the other side, barium could pair up with nitrate. Now it's a +2 to -1 charge. So it's going to be BaNO3 2. Now, technically, in terms of balancing the overall reaction, there would be like 2 of these in relation, but for this lab, all we care about is what's being made. So you just need to write the possible products in each box.
Say something.
All right, guys. So we're part 1 of the vlog squad.
Part 1.
Doing part 1 with all this stuff. Just cleaning off the thing to make sure it's good and quality. All right. Let's see. Okay, so first we're gonna do BaCl. This one right here.
I want to pop it, but like I don't know if that's.
Oh, there it goes. Okay.
And then we'll get the product.
Nice dropping, Taylor.
And then you do your AgNO3. This is some expensive stuff right here.
Wait, so what we write?
Alright, I think that looks cloudy. Can we mix that up a bit?
Yeah, can I get a close-up on that real quick? That looks like a little cloud right there.
Let's see. Yeah, that's cloudy. So
That's for sure cloudy.
So yeah, that's a reaction. All right. So yeah.
Don't fall on the iPad. You write cloudy as observation.
Oh, okay. So what you do now?
I don't have a pencil. I'll be back.
What you do now is you
I got you.
write your observations on this paper of what happened. So here I'm writing the combinations of what happened. So barium nitrate and silver chloride, I think.
You're doing great.
And then I'm also gonna write that it became cloudy. All right. Okay. Now we're just gonna do a bunch of the reactions and kind of not take too many breaks in between. Here we go. Let's grab
Let's
this.
get an epic angle. A top down.
Okay.
Let's see if we can get this top down.
Na2.
Oh no, the lights.
Do you multiply?
All right.
Is it just minus?
Okay.
And then AgNO3. The super expensive stuff for literally no reason.
Is it really expensive?
That's what she said.
You
That wasn't supposed to be funny. Okay, so it became yellow.
said the words.
Okay, here, you need to write all this stuff.
I know. I don't have a pencil. There's my
Yeah,
pencil.
there you go. Okay, write that down. Okay, and now we're gonna do AgNO3 with NH4 2SO4.
I could look it up.
It became yellow and it's cloudy.
Yeah,
How
that's
would it
true.
balance though? If they're bonded beforehand or whatever.
Is that done reaction?
Okay, I don't think that did
That
anything.
did nothing. That's just sitting there.
Yeah,
What is
like
the
90% sure.
charge of
Yeah, so that one didn't do anything, so we're just gonna move on.
So check chlorine's charge.
We're gonna go to lead nitrate. I think that's what it's
Oh, it's
called.
minus
There you
one.
go. And
All
then,
right.
because iron's one of the ones that can
And
vary.
AgNO3.
But since you know
Here
in
we
this
go.
formula you have 3 chlorines to every 1 iron, what would
it's
iron?
plus 3.
There you go. Yep.
Maybe we should give it a sec.
I was like thinking that.
Yeah, that
but then
doesn't
I was
look like it
I
did-
don't
I
think
mean,
it
not
could
all
be
of these are
minus
gonna
6.
react.
Yeah, they're
That's
not.
how it works.
Wait. This one is less cloudy than that one. Maybe that's just the
Or it'd
light.
be
That's
like-
just the light. I changed my
Yeah.
mind.
I'm
it'd just
like
be
90% sure that neither of those did anything.
They are
Okay,
nothing.
so we're going to the, is
Wait,
this
that's the salt. That's like.
okay, this better be Ca and not Ga, because if it's Ga, that would be sad.
Yes, CaNO3.
So we're doing the calcium nitrate here.
Yeah, I don't think she just has gallium.
Yeah.
That'd be kind of scary.
I mean, it looked like.
Sure.
And then with the AgNO3,
The Fe.
dude, none of these are doing anything.
It's quite
would it be
maybe these ones take more
FeOH3 then?
time.
I mean, all of them have been clear so far, so it might be hard for you guys to see on that video, but
We're good.
basically, none of them are really doing anything here. You can get a overhead view of these ones so far. All right.
It's kind of hard because it's laminated, so it's so shiny.
All right. We're just gonna move on.
On to, what is that? KPO.
Potassium
Looks
PO4.
exactly the same as this one.
Phosphate, probably.
Slightly different, but orange one has a yellow tint.
All right.
Just say slightly cloudy.
And then
slightly
you
yellow
got.
on each one.
Yeah.
That is very.
Oh, that one became yellow.
Wow.
Okay.
That's cloudy too.
Go right that way.
Yellow and cloudy.
So yep, yellow and cloudy. It really changed colors a lot. All right, we're gonna go to
G is plus,
Na2CO3.
That's more of a brown than a.
Yeah, that
We
is more
thought it
brown.
was yellow. Now
Okay, so yeah, we're kind of changing this one to brown just so because that's more accurate. Let's see, where's Na2?
They may go through and just.
Aha. Okay, so now we're going to the second row. Yeah, we'll move you guys a bit closer so you can see. Here we go.
Okay.
Okay, Na2CO3. Wait, what am I mixing with that?
Na2CO.
And barium chloride.
Dichloride.
All right.
Ooh, that's got clouds in it.
Yeah. So that one's getting cloudy. You guys, I think you can see
You can
that.
tell. Yeah.
So that's definitely a reaction.
That's cloudy.
Yeah.
That's about it. It's a solid.
So it's like white and cloudy kind of.
It's
Oh, wait, actually,
the barium chloride. It looks like it reacted, and that part became cloudy.
Exactly.
All right.
Okay, now we're moving on. Na2CO3. Dude, shout out to Miss Alviso who prepared all this stuff for us, you
Yeah.
know, so we could set it all, so we could do all the fun stuff.
Yeah.
Here,
Thank you.
Let me wipe this. I just got a bit over here.
That
There we
could be
go.
bad.
Yep.
That could be.
So nothing happened there, so we're just gonna move on.
All right.
Let's see, PbNO3 too.
What's CrO4?
I'm just gonna do that right there.
2 minus.
And let's see.
They're
Na2CO.
the same. They're the same thing.
Oh, they're all the same.
Your neck.
Yeah, it's
Yeah,
just
from
like
bending
reacting
over so
with
much.
each other, I guess.
Oh, this one.
Oh, that's like cloudy. That's like pain.
Yeah. So that one became cloudy.
Very cloudy. White and cloudy.
Yep, white and cloudy. So, yep, you guys can see that pretty well, I think. I'm gonna move it over so you can see these next two.
Okay, here we go.
So it's supposed to
Na2CO3. This one's pretty interesting because it's cool. That's why.
Because of science.
Science, exactly.
Science. That's what yeah, exactly.
Well, that's exactly why. Okay, here we go.
Oh.
Okay, so I'm not sure if you guys can see that, but that one became pretty cloudy. Yep, you can see that. So it's white and cloudy, like a lot of these other ones. Maybe that's a pattern with the Na2CO3, is it becomes cloudy, because, but yeah. All right, and then we're just gonna do this K3PO4 with the Na2.
It's pretty close.
That's the wrong one.
It's like strong.
All right, guys, I'm dumb, but luckily we have this wipe, so we can undo.
Oh, did he do it wrong?
Yeah, I totally did it wrong.
Oh, that's okay. Because the viewers at home are very respectful.
They're forgiving.
They're very forgiving. That's the word I was looking for.
I appreciate your forgiveness, viewers at home. I just did it Na2. Wait.
Did you do it wrong again?
Okay, guys, just don't even worry about it.
Guys, Taylor is normally very on point.
Yes,
He
except
just
for today.
he just makes a few mistakes every once in a while. That's okay.
Yep. Here we go. All right, and then the.
Yeah.
Leaning it down. All right, safety tip for all you at home: don't lean your neck down too much. It hurts after a while.
Maybe get a neck brace.
Well, I'm not sure that would do anything.
That's funny. It looks like there's no precipitant in this.
Yeah, that one, nothing really happened. So we're gonna move on to NH42SO4.
Like, there's like that ring around the outside.
All right. So just make sure you wrote down all the stuff here, and then if you want to right now, you can also write down like what the reactants were, and then we're gonna keep going.
Well, these are all different. Oh wait, they are different colors to start with.
All right. NH42SO4. What did I just put in?
Big drop.
And then
Barium
BAC.
chloride.
Barium chloride. Yeah.
Ooh.
All right. So that one, it became cloudy.
Definite cloud. Definite cloud.
All right, and now we're gonna do that again with the here we're gonna move the iPad a bit down. Let's see, PBNO3. See, the part 2, you guys should be watching Max and Winston. They're pretty good at this kind of stuff.
Obviously not as good as us,
Yeah, slightly worse than us,
but
but
that's besides the point.
Does it fluctuate
they
in between? Like,
they do a good job.
They're good. They have great hair.
They do have great
They
hair.
have beautiful hair.
Better hair than us, that is for sure.
Wow, that's solid white.
Yep, that one became really white and cloudy, like
More.
basically everything else.
Yeah, that's
But
more
yeah,
than
so
that
just
one.
say it stays
you know, it's even a bit more than the one up here. So yeah, not sure if you guys can see that. See, and now we got NH42SO4. My neck is gonna break. That was a bit wet, but that's okay. And CaNO3. All right.
Yes, something.
All right, that one. Really not much of a reaction.
Like a red.
So we're gonna move on to the K3PO4 one with NH42SO4.
It's a lot of numbers. Just roll out your neck. Roll it out.
Okay.
Roll it out. Yep.
Okay, we're ready. Here we
We're
go.
good.
Okay, and then we got our potassium, which is a K, because potassium is okay, and it's yellow because of bananas.
Don't let that deceive you. This potassium is actually clear.
Yes, that is true.
It looks
Disappointing, but true.
very disappointing.
See, but look, This one is yellow.
Depends, like,
Proof
what's
that
charging.
potassium makes bananas yellow.
Oh, and if we go back to this one, the
That one's not
precipitant-
potassium.
I know, but the precipitant in this one is starting to settle.
Oh yeah,
So-
that's true.
Great question. I don't know exactly. So this right here is called iron 3
Okay,
chloride.
you might have to pick.
There's also
Let's
a
see.
compound
I
known
got
as
it.
iron
Okay,
We
that's
can
it.
just flip it to this side.
Yeah, that's a good idea.
All right,
So,
close your eyes if you get
bond
motion sick.
multiple ways.
Yeah, just slide that.
So is it always gonna be iron 3 though? Like,
Slide to the
Like
left.
okay, like in this. So when that yes. So when this
All right,
particular
guys.
There's a
iron
glare.
reacts, it's always gonna be a 3.
okay.
If it was the iron 2 chloride, then it would always be the 2.
Alright.
Does that make sense? So it's kind of like two.
All right, and then
But they
barium
keep their-
chloride.
they behave the same.
See, we're gonna mix that guy up.
Types of it.
Do something. Oh,
Nothing happened.
nothing.
That's what we call pure disappointment. But you know what? You gotta get used to
Wait, just for
disappointment.
timing, everybody, I make sure to do all your reactions first. Because if you need to, you can do the other stuff at home, right? The balancing, but you can't do chemicals at home with
yeah.
you. So I would do all of your
Wait a sec.
drawings, and then you can come back and
Calcium nitrate, everyone. This stuff is cool because it has calcium in it and also nitrate.
Wow, what an insight.
But you know what? It's not cool today.
No,
'cause
it's lame. Nothing happened.
it did nothing. You know, we try to make it interesting for us viewers at home, but we can't control science. Science controls us.
Yes.
Let's
We
see.
should do a PSA on how science controls everyone.
there's actually very similar chemicals.
Do something.
Oh, that was.
Oh no, it's actually doing something.
It is.
everyone.
It's. Oh my gosh.
Guys, everyone, it's cloudy.
Wow.
Clouding up.
Wow. Pure excitement. Yep, they can see that one is definitely cloudy.
Yep.
Wow.
That's a good cloud right there.
Yeah, that is a good cloud.
Let's see.
Great cloud.
Quality cloud.
You heard it here first, folks.
That was
Miso
a.
says it's a great cloud. Oh wait, your hand is. Nobody wants to
Okay,
see your
sorry.
hand. I'm sorry.
Look, so CaNO3, and then we're mixing that with barium chloride.
Okay, these did absolutely nothing.
Okay, that did nothing because it's dumb, but that's okay.
Yeah, it's dumb.
Wait, we need to.
It's okay. I got it.
Okay,
I'm
yeah.
camera guy. I'm camera guy.
Yep.
This is my job.
CaNO3. I'm like Bill Nye, and he's the camera guy who makes it all go down, you know?
Bill Nye
Okay, so then make
with
sure
his
once you're done
camera
that
guy.
you flip around
Exactly.
and write down the observations of the other group.
Bill Nye and his
Let's
camera
see, so,
guy.
let's see, we're going CaNO3. Where is that one? Wait, did I just do that?
Just if you're unsure about what she did, just wipe it up. It's
Yep.
pretty simple. I think that makes sense.
Dude, I think I keep doing it right, and I just forget
Yeah,
whether or not I actually
everyone at home is shaking fists at you right now.
do. They could probably, if they really cared, they could stop the video and go back and be like, yeah, he's kind of stupid.
Yes, please leave hate in the comments for Taylor.
Oh, is that clouding?
Oh yeah, there's
Okay,
a
I'm
slight.
not sure if you
there's a
guys can see
slight
that.
cloud.
Oh, yep, you can see that pretty good right there.
You see, that one Alvisa said was a great cloud. That's a decent cloud.
An okay
An
cloud.
okay cloud,
Mediocre.
at best.
Yes. All right, we just
Last
got one more.
one.
This one's gonna become like a neon orange. I'm calling it right now.
If it's not, I'm gonna just turn the video off.
Nothing.
Except I get paid for this. So I'm not. Oh.
No, it's just white and cloudy. Like
Oh, but that's an above average cloud.
that is an above average cloud. All right, guys. So, as you can see, here's the whole board. Sorry about the reflection. It's kind of bad. Here, I'll zoom out. There you go. All right, guys. This has been a Taylor Brown and
Yeah.
Gavin, and we're
Nobody
signing off.
drafted.
Check.
Is this looking good? Welcome to Vlog Squad. A little bit this way. What?
Alright.
Okay, let me. Is it started?
Yeah.
Oh, it is?
Well, I can just delete that part.
Okay. Welcome to Vlog Squad. Vlog Squad 2. Let's get right into it. Okay. So, here, we'll take the camera. I believe first we're going to start with NaOH and FeCl3. Let's find these things on here.
So, are we just...
We're just combining these things on this paper right here. Yeah, I don't think we need this right now. Yeah, they're just mixing, bro. They're just mixing straight up, bro. Okay, so we have a bunch of droppers. So this one is NaSO4. We're looking for NaOH. NaOH. Oh, nice. And then this one is FeCl. Okay, so do you want to put yours on first, or do you want me to put mine on? Alright. Put a couple drops on there.
You're not the first one.
Brilliant. That was the NaOH. Here you go. Now we've got the FeCl3. Watch for a color change or something of the sort. Can you see it? Oh. That's awkward. Did anything at all change? I mean, it looks like they just mixed. Wait. Interesting.
Once again, focus on the data right
know,
now. So do all the
It
reactions.
really looks like this one didn't change. Alright, looks like that's supposed to happen.
That did nothing. That's just
What is this?
I don't think it changed. Alright. Alright, guys.
Next
Amazing.
reaction.
Okay. Should we just go down the FACLs and do all of them?
Sure.
And go FeCl3. Alright. Smart again. Let's put 3 drops. It's
My
1.
camera's moist.
Come on, bro. Pop that bubble. 2, 3. I really don't like that bubble, but can't touch it. So, okay, and then
MGBR. Oh, the bubble went away.
So we're going to
This will get really tricky if they all start.
alright, did it change at all again?
Staying nice little circles.
It looks like here. Will you hold this? I can't hold a vial and I can't. It looks like it once again did not change like it whatsoever. I'm gonna double check that this is what is supposed to be happening. I don't know if we're doing this right, but neither of these have changed whatsoever.
Maybe they didn't.
Well, I guess not.
basically
What does it mean if it doesn't change?
They didn't
It's
react.
just not strong enough to like.
They just all they're all spectators. No one wants to.
Yeah, nobody wants to bond it. It's not strong enough to do it.
Sometimes happens. So
Bronze! Just had to make sure we were doing it right. Okay, looks like we're looking for. Yep. Yeah, you can put yours on first. Oh, sorry, guys.
Here, do you want me to just do all the drops and you can film?
Yes.
Okay.
Alright, we're looking right here at the FACL and KO. No, K2CO3.
oh, that one became
Wow. That's cloudy too, right? Yellow and cloudy.
yep, yellow and cloudy. It really changed colors a lot.
Oh, look at that one.
CO2.
Dude, there's no. Here, wait. Don't have my phone. I'm gonna get a flashlight. Don't have my phone. Well, trust me, guys, when I say that changed color. Oh, flip, bro. It's like. What color is that? I'm colorblind.
Urine.
Orange. Okay. Moving on.
Okay, let's see. What's next?
Oh, we should probably write these down, but we'll write them in a second. We'll finish all the reactions first. Alright, so looks like we're gonna do PB nitrate. So lead nitrate 2. Oh wait, no, it is here. On the iron chloride. Yeah, I don't know, man.
I don't
What do
think
we-
we have it.
Yeah, hold the...
PB. Oh, here it is.
Okay.
PB3.
Alright, this is what they look like. Looking good. Let's do this thing. Alright, looking pretty clear so far. Sorry.
Prepared all this stuff for us, you know, so we can set it up, so we can do all this fun stuff.
Yeah, thank you.
Let me wipe this.
That could be bad.
Yeah.
That could be.
So, nothing happened there, so we're just
Seems to have not changed at all. Wait, did it get lighter? No. It seems to have not changed at all, comparably to these ones. So, did it change?
I mean, it got lighter, but
That might have just been from the drops you put in, from the lighter one.
So, it became cloudy.
Very cloudy, light cloudy.
Yeah, night cloudy, so, yeah, you guys can see that pretty well, I think.
Alright. In the meantime, oh wait. Alright, no change. Seems FeCl3 does not react much. Alright, in the meantime, if it's your birthday, shout out to you. Happy birthday to you. Happy birthday to you. Happy birthday to chemistry person. And happy birthday to you. Grand.
right.
Oh, look at that one. It got also different color. Can't tell what color, but like it's different. Whoa. Alright, so that's what happened with those ones. That now concludes our FaCl3. Grand. Yo, you want to trade me for the next row?
Sure.
Grand. Here. Switch the spots, bro.
Viewers at home are very respectful. They're forgiving. They're very forgiving. That's the word.
That makes sense. That makes sense. Thank you. Alright, so we got NaOH here. NaOH does not is not used on the next. Oh, I guess it is. Huh. My bad.
So we just don't do this at all?
Right. Well, yes, because that's NaOH, NaOH. Doesn't react with itself.
Oh, yeah, sure.
Come on, man. It keeps getting those air bubbles in there. Well, that one's looking awfully clear with an air bubble. Okay. Oh, wait.
You just have to hold that one.
I'll just hang on to it. Anyway, which one did we take from those? It was like the magnesium one.
GBR2. Well, we have to have that one
Alright,
still.
I'll just pretend. Okay, and then we're doing magnesium one. Oh yeah, that's the magnesium one. I was holding it. Alright, two clear substances. Will they react?
So, just
Probably.
you wrote down all the stuff here, and then if you want to right now, you can also
Not.
write down like what the reactants were.
Alright, looks like there was no change on that one. Alright, and then what's the next? K? Let's see what happens with here. This one here. Oh, very not changed. Incredible, you guys. Incredible. Yeah. It's like. Okay, here we go. Third one coming in. This one's gonna react. I can feel it. Let's see. It is FE, right? Nope, it is PB. There's our PB. Here it is. Guys, I can feel this one. It's going to change.
Yeah, slightly worse than
But that's besides the point.
Okay, I could hear that.
Yeah, you spilled the drop on me.
My bad. We can wipe it off, but I was wrong, you guys. That one didn't react. Watch none of these react, honestly.
became really white and cloudy. Like,
I'm just gonna finish off both of these. Okay. And now NAS. NAS.
so yeah, not sure if you guys can see that.
None of these are gonna react. Alright, NaCr, maybe? The final option, which is actually yellow first. Alright, here we go. Oh, wait. It's literally just this color. I don't think any of them reacted.
Yeah.
Ridiculous.
Alright.
Okay.
NaOH,
Let me.
pretty much non-reactive.
Alright. Here's the next one.
Thank you.
Yes, sir. So none of those reacted as far as we know. So now we're on magnesium bromide.
We're good.
Okay, and then we got our potassium, which is a K. Potassium is okay, and it's yellow because it is.
Don't let that deceive you. This potassium is actually clear.
Yes, that is true. Disappointing, but true.
Very disappointing. Nothing
Alright, it looked very unreactant. Unreactant. Okay, here, wait. Camera, I'm gonna put you down for 1 second. Let me wipe that off.
The precipitant in this one is starting to settle. So,
Great question. I don't know exactly. It's like, so this right here is called iron 3 chloride. There's also a compound known as iron iron.
Which way did you drag the
right.
bottom?
Down.
Down this way. Like, did you go diagonally?
I went down.
Okay, sweet.
Put it like in the camera.
Like,
And I was
oh,
like,
in this, so when that, yes. So when this particular iron reacts, it's always gonna be 3. If it was the iron 2 chloride, then it would always be 2.
EB.
Does that make sense? So it's kind of like two different types of
Right, and then,
iron, but they,
EB,
the way
NO3.
they produce the same. There's 2 different types.
do something.
nothing happened. That should be called.
This is ridiculous, you guys. Nothing's reacting.
Hey, just for timing everybody, I'd make sure to do all your reactions first. Because if you need to, you can do the other stuff at home, right? The balancing. But you can't
They
take
can
chemicals
see
home with you.
the
So I would do all of your droppings,
the
and then you
what
can
we're
come
reacting
back
with,
and.
right?
Oh, of course. Sorry, guys.
Wow. What an
Trying to
insight.
give you an up-close view. Okay, these two are reacting. Oh,
No, it's lame. Nothing happened.
It did nothing.
once again, nothing happened. Wait, is it looking a little cloudy, maybe? No, it's not. Not even kind of.
Just my goggles.
Yes.
Cool.
You should do a PSA.
There's a lot of white. Yeah. There's actually very few chemicals
Do something.
that are. There's not
Oh,
as many.
no, it's-
Oh, no one's actually doing something.
It is. It's. Oh my gosh.
Guys, everyone, cloudy.
It just doesn't look
Wow.
Clouding up.
just because there's
Wow. Pure excitement.
Just for the people at home, I would like to let you know that there's a super cool trick that you can do, and it involves fire. And so if that's your thing, then I have great news for you.
Here first.
I have an experiment we should try or something. I don't know. Anyway, so what you're gonna do is you're gonna get like a spoonful of cornstarch and put it in your mouth, and then you
That's
blow
a
it
bad
out
idea.
onto a flame, and it blows like fire.
Isn't there like side experiments to do at home?
Yeah.
Alright, non-reactive looks like.
Nothing reacted. Woo.
See, because the color of
That starts
this
in yellow.
is yellow. So these bottom two,
They didn't react.
they didn't.
Okay, so
Nothing
then
at all.
make sure once you're done that you flip
Okay.
around and write down the
Okay.
options.
Good boy.
The other group.
Okay, CO3. Here goes.
Thank you. Okay, KCO3. Here's what we're gonna do. We're just gonna go speedy quick. We're gonna go 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, we have all our drops there. Now what do we need first? PbNO3. 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 Alright, PbNO3, our first reactant, if it reacts. 1, 2, 3. Oh wait, is that cloudy? Oh,
Yeah, that's a lot more cloudy.
that one got cloudy, you guys.
That one is reactive. So that was.
Oh, that one reacted. How crazy was that, you guys? We got one. Alright. Na. 1, 2, 3. Looks like that's non-reactant. Yeah, that was SO4. NaCr. NaCr. Okay, remember, keep in mind this one starts yellow, so it might not react. 1, 2, 3. I don't think that one reacted either. It did not.
Those are the same color if you can't tell.
PbNO3.
So,
Here you go, man.
Alright.
Moving quick. Look at the split. Alright, so we had that one that reacted up there.
alright guys.
Starts off clear,
This has been
as typical.
Taylor Brown.
Yeah.
We're signing off. Wait, I did?
Yeah, that's funny.
Wait, when did I start a new video?
Oh, look at that, you guys.
Yo, this is nothing, right? That's nothing.
That one got... Okay, so that's a clear one. And there's that one. What happened to that one, you guys? I'm not going to give you the answer, but it's cloudy.
You know, like, there's a medium amount of ridiculousness that you're allowed to.
Alright, that one starts clear once again. Combining with NaCr. Remember, this is lead nitrate too. I don't think you say the two though, I think it's just lead nitrate. Okay, looking at this one, this is yellow. Yep. Oh, wait. You see that? What's the difference between those two?
Solid in it.
That's looking awfully
Dude,
cloudy to
all you
me.
guys are so cool. We just got white and cloudy.
Yeah, like every single time. White and cloudy. White and cloudy.
Alright, NaSO4. Why don't you just do this one, just finish it out, because you have both of them in your hands.
But that's what happens to bananas over time.
That's true. This makes perfect sense.
Alright, it starts nice and clear and yellow. That's weird. Alright, final reactant. Let's get an up close view on this one.
Yo, that percentage completely settled. Okay, not really, but it's pretty settled.
What a letdown.
What a disappointing ending, you guys. Anyway, this has been your vlog squad. Mina, you should have been here. Would have been great.
But
Even though
you're
you
dancing, so.
you are dancing, so I guess
And
that's
at
cool too.
Disneyland.
What?
Alright, once you get
kinda
all
jealous,
your
but it's fine.
reactions
Everyone
and
else
all
is
your
at home.
data down, then go ahead and
Sorry you're at
do that,
home.
and we
Wish
can
we
go
could
back
meet
to the
you,
classroom
or
to
have you here, whatever.
analyze it all.
This is Max. I'm Winston. That's the rest of the group, whatever. Goodbye. Wait.
Here is a final look of the reactants. Thank you.
Okay, so from the lab, you should have determined, right, whether things were cloudy or whether they were clear. Some of them colored cloudy, some not, but that's the biggest thing. What does it tell me if it turned cloudy? It's good. There's a reaction, there's a precipitant, and the precipitant is one of these two things. Now, the goal of this lab is to determine which ones are the precipitants without using the solubility rules chart. So we're only doing it based off of data, okay? So if you go to your lab packet, okay, turn to the second page. This list is where you are going to sort everything you made into soluble or insoluble. Once again, reminding you that insoluble means it's a precipitant, soluble means it just is, they're just floating around, those are your spectators, okay? Now, the reason why I gave you 2 identical tables is just because sometimes in the sorting process, it gets a little messy. If it's too messy for me to read, I ask that you rewrite down here. If this table is understandable for me, then you don't have to rewrite your answer. But just because there's quite a bit of crossing off and moving and changing, sometimes it gets a little messy when you're problem solving this out. Okay, so that's why there's 2 of these boxes. Now, let's start with the soluble list. So how do I know if something is soluble? It's just dissolved, right? So what does it look like? Water. Clear, or mostly water, right? So first off, we know that all the things we started with are soluble, right? So all the things you use would go in the soluble substance list. Okay, yes, there's a lot of sorting that's going to go on here. Now, there's another thing that we can also, there's other times when we can guarantee things are soluble, and that's from the reactions. If you didn't see anything happen when you mix 2 things together, what does that tell you? Both the reactants are soluble and both the possible products are also soluble. So, for example, in this box right here, our possible products are NH4NO3 and Ag2SO4. Since it went clear, that tells me these weren't even made and everything just stayed separate. So you'll go through all of your clear boxes and add those to the soluble list as well. Okay? Now, how do I determine what's insoluble? Any thoughts?
There's a reaction.
Okay, so good. If there's a reaction, I know one of these 2.
Oh, and this paper.
No, we're not using our rules.
Cheater, put it away.
From our data, how could I determine?
You have to like determine if it's polar or not.
Ooh, not a bad thought, but nope. These are all ionic things, so they're actually just all positive and negatives.
If there's potassium.
I don't even want you to really use the memorized rule. I want you to try to just do it based off your data.
You could compare the other ones to each other.
Very good. Compare your list. If one of these shows up in the soluble list, and by default this one does, I know that this is my precipitant. Once you identify the precipitant, I do want you to circle it or highlight it on your data chart. And then you'll list them in the insoluble list here. Okay? Questions on your analysis. Once you get your analysis done, then you can answer the post-lab questions. Okay? There is no lab report for this lab. It's just completing the packet, so you don't have to do anything separate. Just a reminder for some of you, because some of you are close to your limit or almost over your limit, that you only get 3 late lab passes for the year before they get docked to 60%. So if you've already used those, don't let this one be late. Or if you haven't, right, make sure you know accordingly. Okay, but we have all the way till December 11th because you always get 2 class periods before it's due. So if you have questions between now and then, please let me know. But we got about 10 minutes left, so you keep working with your neighbors and either do your products or start sorting things out. Okay? All right, let me know if you need any help.
Oh yeah,